Hello everyone, welcome. This video is going to be about why do we need databases and choosing the right database for your application. So first of all, why do we need database? Databases are important because all the websites, you choose any kind of website, be it social media website needs to store user comments, the likes, shares on user posts. uh, in case of e-commerce website, the website needs to store the data of the products that they are listing on their website. Okay, what features that product have, it needs to store that kind of data, what kind of warranty that product will have. Social media video streaming websites need to store the videos itself. Then websites like Amazon Prime also stores the data about the actors that are acting in that particular video. Okay, it displays that information as well. Then educational websites needs to store videos again. If the instructing medium is in the form of videos, they may store slides, or they may store content in the form of text as well. So all the website needs to store data, right? Now where will this data be stored? The data is stored in the databases. Now there are multiple databases available in market. Can you use any database for any kind of application? Roughly speaking, yes, you can use any kind of database. What will happen if you use any kind of database? So will the functional features be affected? No, the functional features will not actually be affected, because if you want to store, let's say, information about username and password, username and password could be stored anywhere, like in MySQL or in MongoDB. Okay, so you can store particular data in relational database as well, and you can store it in non-relational database as well. Your functional requirements will not be affected by what database you choose. What will actually be affected is the non-functional requirements. So whenever you are designing a system, your system has committed to certain kind of non-functional requirements like scalability, like consistency, the speed with which your database responds. Okay, so these kind of non-functional requirements will get affected by what database you choose. Now, databases are broadly categorized into SQL and NoSQL databases, like relational and non-relational databases, right? So choosing the right database is important. Now, how to choose the right database? In order to choose the right database, you need to understand the structure of data, the kind of data you want to store. Okay, we'll be understanding that now. So consider case of an engineering college who wants to store data about their students. Okay, so what data will they store about students? They will store name, roll number, branch, and year. Okay, so assuming that student is an entity and it has got these attributes. Okay, now will these attributes change for every student? Will you need to store something else for? So basically, will you find this data for all students? Each student will have name, each student will have roll number, each student will have branch, and each student will have year in which he is studying, right? So for such kind of data, you can store it very easily in the form of table. Okay, so in the table, the row represents an entity and the columns represent attribute. Okay, and for each student, that is for each entity, all the attributes are going to be same. All the attributes are going to be same. Each student will have roll number, name, branch, and year. Okay. Now this kind of data can also be stored in the form of document, right? So each document represents an entity and all the attributes can be mentioned in the document. So the thing to note here is that whenever you have uniform data, you can store it in either tabular format, that is in relational database, or you can store it in document format, or NoSQL database, non-relational database. There are a lot of non-relational databases like key value pair, document, etc. You can store it in that format as well. Now consider case of a website which stores the data about or configuration about different electronic items. So user can come to that website, compare the electronic items, and based on that they can choose to decide what they want to buy. Okay. Now electronic item can be different items, right? So for in this example we are considering case of a mobile phone and a washing machine. Now what attributes about mobile phone do you need to store? You need to store the RAM present in mobile phone, the storage, how many megapixels does the front camera have, and how many megapixels does the back camera have. Okay. Consider case of a washing machine. So what attributes about washing machine do you need to store? You need to store star rating. Is it a 3 star, 4 star, 5 star washing machine? You need to store load type, whether it is front load or top load. You need to store the capacity of washing machine, whether it is 3 kg, 4 kg, 10 kg, 7 kg, whatever the kind of washing machine it is, right? So now you see, in this case, different electronic items will have different features. Okay. So this kind of data is hard to store in a single table. If you see, mobile phone has got 4 features, but washing machine has got only 3 features. There is no fourth feature. So the point to be noted here is that the data is not uniform. The data that you need to store is not uniform. It changes. Okay? But this kind of data can easily be stored in the form of documents or in non-relational database. How? Each document represents an entity, and each document can have different attributes. Okay? Mobile phone can easily have RAM, storage, camera megapixel, back camera megapixel, and another document for washing machine, load type, star rating, capacity in kg, right? So it can easily stored in form of documents. So far from the discussion, we got to know what kind of data can be conveniently stored in what kind of database. Okay? But there is more to it. Now we'll be discussing various attributes based on which you should decide what data should go where. Okay? Okay. So first, uh, for the data to be stored in relational databases, the data should have, you need to predefine a particular schema. Okay? The kind of data, the attributes of the data that you want to store needs to be uniform. Okay? Only then you can store it in the form of relational database. So you need uniform predefined schema. But in case of non-relational database, there is no such requirement. So it can store unstructured data as well. So in relational databases, you need to define schema beforehand, and changing that schema would be very cumbersome once you have stored the data. But in case of non-relational database, you need not define schema beforehand. You can change it on the go. For each as the requirements change, you can change the like schema. There is no rigid schema. You can store unstructured data in the non-relational databases as well. Okay. Another important property of relational database is that it is ACID compliant. ACID means atomicity, consistency, isolation, and durability. What is meant by this? So atomicity means that all the actions or all the steps that you need to do will be done in form of a bundle. So either all of them are going to be done or none of them would be done. There would be no intermediate. Like if there are 2 steps involved in one particular transaction, then either both of them would be done or none of them would be done. So how do we understand atomicity? Let's say there is a banking application, and there is an account X and there is an account Y. Now in order to transfer money from account X to Y, you need to deduct from account X and you need to credit in account Y. So this debit from account X and credit in account Y, these two things should happen together. It cannot happen that once the deduction is done and because of some failure the system has gone offline and credit has not happened. This is not acceptable in banking application, right? So either both deduct and credit will happen or none of them would happen. So relational databases are compliant with this. Relational database follow atomicity. Okay? Then there comes consistency. What is meaning of consistency? So say before this transaction happened, debit and credit, the amount present in account X was 100 rupees and the amount present in account Y was 500 rupees. Okay? So before the transaction, the total amount in X and Y was 600, and after transaction the sum of amounts present in both X and Y should also be 600. Why? Let's say 50 rupees was transferred from account X to account Y. Okay? So after transaction the amount with X should be 50 and the amount in account Y should be 550. So afterwards also the total of both accounts should be 600 only. So the database should be consistent before and after transaction. Okay? There is third property known as isolation. What is meant by isolation? There are multiple such transactions happening in with respect to the database, but one transaction should not disturb the occurrence of another transaction. Okay? While this transaction was happening, the amount was being debited and credited to account from account X to Y. There was some another transaction happening between account W and account Z. So this transaction, the transaction between X and Y, should not disturb or intervene with the transaction between W and Z. This is known as isolation. And the last property is durability. What is meant by durability? All the changes that have happened on the database should go into the persistent storage. So these are the asset properties. I hope you would have understood them. And relational database are compliant with the asset properties. Non-relational databases are not very compliant with asset properties. So whenever you want that your transactions should be compliant with asset properties, you should go for relational databases. Otherwise you can go with non-relational databases as well. Okay? Then comes the third parameter, that is querying. So relational databases can handle very complex queries. There could be multiple tables in the database or multiple relations in the database, and you can apply very complex, very big queries on relational databases very easily. But this is not the case in the case of non-relational databases. Non-relational databases do not perform very well on very complex queries. So whenever you have complex queries in your database, you can go with the relational databases. Okay. The fourth and important parameter is scaling. So as your data grows, you need to scale. You cannot store all the data in a single server, single database server, right? Now, relational databases are very hard to scale horizontally. So when there are multiple servers, when you want to scale horizontally, there would be multiple servers, right? Now you cannot break the data and store it in different servers. The problem is that the multiple tables could be related to each other. So these related tables should be present in, it is um, uh, convenient to store them in the same database server. If you store them in different database server, when you run complex queries, the query would ideally run on the single server only. So if there is a server A and server B, if there is this server A and there is this server B, and let's say our student table got very huge and we had to split in two different database servers, right? So if you run query on this particular server, it will only fetch the results of the table that is present in this particular server. So also there could be multiple tables which are related to each other. So query is such that it is accessing data from multiple tables. If one table is stored in this server and another table is stored in this server, then the complicated query would not run fine. Okay? It will give incomplete results. So in case of scaling, relational databases are supposed to be stored vertically. Means it is convenient to scale the relational databases vertically, whereas non-relational databases, they can very easily be scaled horizontally. There are multiple servers, you can store different documents in different servers, and that would be absolutely fine. So relational databases can be scaled vertically. By meaning of scaling vertically, I mean to say that it is convenient to scale vertically, it is difficult to scale horizontally. It does not mean that it cannot be scaled horizontally. It can be scaled horizontally, but there are other complications involved. Whereas non-relational databases can be stored horizontally, scaled horizontally. Now, when data is huge, you have lot of data, and when you run queries on relational databases will respond to the query slow in comparison to non-relational databases. So non-relational databases are famous for being scaled horizontally and for their speed as well. So they are fast in comparison to relational databases. So these are some of the important differences between relational and non-relational databases, broadly speaking. Based on your requirements, you can choose what database you need to use. Now, it is not necessary that your application will strictly be using relational database only or non-relational database only. It can happen that you have multiple parts of the system, and different parts of the system can use different kind of database based on what is the kind of application you are using it for. Okay? I hope you would have understood this. Thank you.